So I welcome you to our monthly New Jersey Building Electrification webinar. My name is Steve Miller, and I'm sorry I didn't actually change my name.
That's okay.
Well, people are going to continue to join. And so now I'm officially Steve Miller in my picture and my title. I host most of these, not all, of these monthly electrification webinars. And it's always the third Thursday at 7 p.m. So you're welcome to join us in a month. We have about 100 registrants for tonight's meeting. The registrants will each receive links to the recording and links to the graphics. And my wife, Pat Miller, is on this, and she's going to handle questions, and she's going to give you a little bit of instruction.
So we're going to have questions at the end of each talk. We have 3 talks, and if you have a question that you think of during a talk, then please put it in the chat, and I'll read at the end of the talk, I'll read the questions in the chat. And after those questions, if you think of another question, then you can raise your hand. And remember, the raise hand is under the reactions icon at the bottom of the screen. And then I'll ask you to unmute and you can ask your question at that point. So, and then at the end, after all of them, we can have more questions.
So the agenda will have 3 speakers for those who've just joined us. Chris Wisniewski is the principal of his company, Integrate Comfort Systems. He's going to lead off with his company's role in building electrification and other things he does. Our second speaker is Franci, who's an apartment owner and who's a satisfied customer of Chris. And our final speaker will be both Patsy and David from Central Jersey. The photo that when you got your invitation for this, the photo at the top is their building, their home. And that tells a lot about their story tonight. So first, let me introduce Chris Wisniewski. His HVAC service company is called Integrate Comfort Systems. It serves northern New Jersey and I guess it's metropolitan New York.
Correct.
And Chris also installs solar and is licensed in multiple states. Now, there's a growing movement for customers to move their house to net zero energy. I don't think many people would know that term, but by installing rooftop solar and changing all their appliances, including the HVAC, heating, cooling, to electric power, that customer can become a net zero energy building. So, so with that, I'd like to introduce Chris. And Chris, it's your turn to talk.
Sure. Thank you, Steve. Thank you, Sierra Club, for having me. I'm just going to take a second here to open up a presentation. So, Chris Wisniewski, I'm Vice President of Integrate Comfort Systems. I have a background in architecture, mechanical engineering, and the company I'm with, my father started a company. The company I'm with started doing more commercial work in the beginning. We have a 30-year history of doing not just commercial work, but specialized work around New York City. And that kind of leads us into the story of us. There's a little graphic here. 2004, ICS buys the first Daikin VRF system. So VRF is a new technology. Well, not new anymore, but in 2004 is a new technology in the United States. We were the first ones to install a system here in the New York City area. And that was really the introduction of what heat pumps are really capable of, because heat pumps have existed for a while, and I'll get into heat pumps. I'm quickly going to just jump through the kinds of projects we do: commercial, residential, churches, things of that sort, huge residential projects. So we've had experience with everything from your standard air conditioning systems to large commercial systems to chillers to cooling towers. But the most popular thing recently, the streak that we're on, is really dealing with residential customers. And an overwhelming majority of customers were able to convert to essentially heat pumps. And I'll go into that. So the word heat pump, I know many people hear it and many people don't understand it. It's kind of a stupid name. People think of a pump. Every time I say heat pump, they ask, well, what's the pump for? So really a heat pump is an air conditioner that just runs in reverse. That's really it. So it's a silly name for it. Technically, it describes what it does pretty well. Unlike your boiler or furnace, which makes fire inside the house and actually creates heat, heat pump just pumps heat from the outside to the inside. So it's a transfer of heat. And I know we have no issues understanding that heat exists right now in a day like today, but there's, in the scientific world, when it's 0 degrees outside, there's still heat, and you can capture that heat and bring it inside your house. That's essentially what a heat pump is. So heat pumps, I mean, there's a lot of reasons why people would want to choose heat pumps over any kind of other source of heating. And it's not just about energy efficiency a lot of times. Number one thing is comfort. And I'll go more, but another is remove danger. I know the Sierra Club's the general out there isn't quite into electrification, but there's a segment of people that are into removing the from your house, such as fire and carbon monoxide. And I actually have a client right now I'm working with. He got rid of everything in his house, not because of environmental reasons. It's because he had a family member that unfortunately had carbon monoxide accident not too long ago. And he's scared and he wants everything that could potentially create carbon monoxide out of his house. So there's many reasons to talk about heat pumps. Electrification is one. The other is we all hate oil. Nobody likes oil. Propane or electric is another way of heating, but they're expensive. And of course, that's the danger I just talked about. And that danger, which is carbon monoxide, kills about 430 people each year. So it's a real concern. You're basically, anytime you bring a fossil fuel in the house, oil, gas, and you have furnace or boiler, anything that burns, makes a fire, there's a potential for carbon monoxide. You don't have that with a heat pump. One of the crucial things when you think about getting a heat pump for your house is that the kind of heating a heat pump gives you is totally different between, again, a boiler, a gas boiler, or a gas furnace. Gas boiler, gas furnace, you inject gas in it, you make a fire, you have sudden heat. It can heat up really fast. A heat pump works very different. So sizing a heat pump is very, very important. There's nuances to it. So whoever is doing a project for you, one of the most important things to understand is really how much heating does your house require? There's a lot of different factors to it, but in the industry, it starts off with a thing called a manual J calculation. And anybody that is considering doing a heat pump should have a manual J calculation done. On top of other things, I mean, if your house is drafty and old, you have to consider possibly doing a thing called a blower door test and figuring out exactly how much loss of heat your house has to dial in the sizing of the heat pump. Not only is the actual sizing important, but then choosing the correct piece of equipment is very, very important as well. And unfortunately, a lot of contractors who do heat pumps don't understand this aspect either, because they'll look at a heat pump and they go, it's a heat pump. Well, heat pumps have very different performances. It's just, if you wanted to win a marathon, would you get the guy who does the 100-yard sprint the fastest, right? Probably not. So it's the same thing. There's heat pumps and there's heat pumps that perform in cold weather. And they're actually called cold weather heat pumps. And in our climate in New Jersey, if you're relying on a heat pump to heat your home, it should be a cold weather heat pump. And most manufacturers, depending on the manufacturer, will, the cold weather heat pump will perform down to -5 degrees outside or -13 degrees outside, things of that sort. So not only sizing is correct, but choosing the correct equipment. This kind of talks about what I just talked about. And here's a graph, here's a graph that represents exactly what the differences are in all kinds of equipment. So we have logged here about, about 12 or so different manufacturers and their heat pumps. And unlike a boiler or a furnace, which is kind of has a very linear type output of heat, it doesn't matter if a furnace is on. It honestly doesn't matter if it's 5 degrees outside or 55 degrees outside. That furnace will perform and will put out a certain amount of heat. Well, a heat pump is very much affected by the outdoor temperatures. So as the outdoor temperatures start to drop, the performance of a heat pump starts to drop as well. So you really want to know, what is that heat pump doing when it's 5 degrees outside, when it's 10 degrees outside, right? We rarely get those days, but we do get them. We even get those days in the negatives. So if you look at this graph, there's certain units there that only go down to about 5 degrees or 2 degrees outside, and past that they can't heat. So would you want a system in your house on one of those crazy nights where it's -2 or whatever it happens to be in our area? So getting the right equipment is obviously key. Now, heat pumps are better at comfort, and I'll explain why. The kinds of heat pumps that you would want in your house should be inverters. Those are, there's cheap heat pumps. They'll do a wonderful job for people down south in North Carolina, South Carolina, if you want to use a heat pump for heat. But over here, everything, choosing the right style of heat pump is key. So an inverter is something that can ramp up and down in performance. It basically, it's like a dimmer switch on a light. So it doesn't have just a simple on-off operation. And because it can modulate, ramp up and down, it can meet demand, and therefore it can provide comfortable sort of heating. So skip the slide here. I think I know what I want to talk about. So there's many ways of executing a heat pump, by the way, right? So a heat pump, if anybody has a existing air conditioning system, you could easily change it out and make that into a heat pump, right? The thing is that AC system and the ductwork it's connected to, is that going to be sized correctly to meet your heating demands? And in New Jersey, the answer is probably no. The air conditioning size, the ductwork size, it's sized to meet your cooling needs. If you're going to put a heat pump in, it's going to provide you the same BTUs more or less as the cooling. So it won't be the only kind of heating you could use in your house. But you don't necessarily even have to do a ducted unit. You could do ductless, and there's advantages of ducted versus ductless. Ductless, obviously, you get coverage in multiple rooms, and you have control over each room in a separate temperature setting, and you get a little more finite with your efficiency, and you can have rooms of the house that are colder, rooms of the house that are warmer. Also, one of the things that you have to consider, and I mentioned before, it's sizing, is that the smallest high efficiency furnace is going to be 60,000 BTUs. The largest heat pump is going to be 60,000 BTUs. So heat pumps are a lot smaller than furnaces, but the good thing about this is that most homes don't need, I guarantee you, everyone that's got a furnace or a boiler in their house, I can put my money on it, it's probably oversized. So it's a big, huge energy hog. So one of the beautiful things about heat pumps is that you do that load calculation, you dial in the sizing, and now you get the amount of BTUs really need. And again, you have that dimmer switch effect where you can deliver, the smallest 6,000 BTU heat pump can modulate to 1,600 BTUs. A furnace can't do that. A furnace would just put out a lot of heat. So you gain comfort with heat pump versus a furnace. I don't know if anybody's heard the term hybrid heat pump. All that really means is that there's another source of heat. And it's probably one of the most popular solutions because, again, can your house be fully heated by a heat pump? That's the question. A lot of homes can't because a couple of reasons. So the size of the home is so big that you need additional units, which people aren't willing to spend money on. Or just basically there's no provision to get a unit big enough that's one single unit that can handle your heating needs. So what happens is that you install a hybrid system. A hybrid system is basically you could have a furnace and a heat pump in one. And the majority of the time in the winter, it's going to be 40, 30s, maybe into 20s, the majority of the winter time. It's in terms of the outdoor temperature. your heat pump will do just fine. It's only when it starts to get into the low 20s, the teens, and lower temperatures, your furnace might kick on. So even if you don't go full heat pump, you're still offsetting a good amount of your energy usage towards a heat pump, and only using that hybrid solution, whether it be a furnace or a boiler, for a smaller fraction of of the winter. So cost-wise, now, the worst thing you can have is electric resistance heater. That will cost you the most. Propane's expensive, oil is expensive. Now, electric heat pump in the majority of the country is a clear winner in terms of energy usage, clear winner. In our part of the country, natural gas has been just artificially priced very low. So if you take the highest efficiency furnace, it's probably going to cost you a little bit less than to run a heat pump. But that's if you take the highest efficiency furnace. Now, that's shifting though. The price of natural gas has become, I believe it's 40% higher over this winter, and it's going to keep going up too. So there's a point in time where they're neck and neck, and the future really says a heat pump will cost you less to heat your home. So if you're transitioning to have your home electrified, right, then next, if you're getting off gas, or at least offsetting the usage of the gas, and you're installing an electric heat pump, and you're getting that EV vehicle, you're just adding more electric usage. So the next logical step for you would be solar, right? And solar is a little bit different in terms of solar is a very clear financial investment. So what I mean by that is that usually the majority of homes, we can find a way where you lower your electric bill, right? So you're saving money. You're obviously, offsetting your carbon footprint and doing all that stuff. And you're winning from day one in terms of financial, solutions. You get a brand new heat pump, anything else in your house, you're paying for it, you're enjoying it. Of course, it's an investment in your home, but financially, you're not sort of gaining on it from day one. With solar, there's definitely a possibility that you're gaining on it day one. It's a couple of reasons. Number one, there is no doubt that electric utility costs go up year after year after year after year. The utility companies don't lower their rates, right? So when you get solar, you're pretty much, imagine if you went to the gas station in 2019 and you were paying $2, a gallon, you're locking yourself into that price. And whatever happens after 2019 with gas prices, you don't care. That's essentially solar. You're locking yourself into a certain cost, and you're offsetting the fact that 10 years in the future, you're going to be paying, incrementally a lot more. On top of it, I know everybody's probably aware of the new IRA, the Inflation Reduction Act that passed through, but the tax credit went up from 26% to 30%, which is wonderful. So whatever solar project you do, you get 30% of it back in tax, assuming you own tax, of course. And New Jersey is one of the few states that still has the program, which is wonderful. So basically, New Jersey pays you to go solar. So for every 1,000 kilowatts you produce, you get $90 from New Jersey. So whether you use it or you don't use it, doesn't matter. It's whatever you produce on your solar panels, the state still pays you. And that's kind of important because a lot of the early adapter states like California, Nevada, and all those states, they had these programs in place. And then once the states got a certain threshold of people going solar, they did away with them. So New Jersey still has them, but it's got a limited life. I mean, it's predicted in about 2 years or so, New Jersey will meet their threshold and this program will no longer exist for new people. It's still grandfathered for anybody that's getting it now. So a lot of financial reasons for people to go solar. I would take any questions. Basically, that's sort of the overview of heat pumps and really fast in one. If there's any questions anybody has, I didn't dive deep. I don't want to blow anybody's brain up, but I'll be happy to answer questions.
Michael Heller has his hand raised. I want to say I'm looking for the chat on my screen, and I do not have a chat on my screen. I've never seen one that's like this. But so if you have a question, please do what Michael did. raise your hand, and Michael can speak first and ask his question.
Thank you, Chris. This was really amazing. I'm a homeowner who is embarked down some of the roads that you've talked about. We have solar on our house. We have cold weather heat pump for our second and third floors of the house. But our main heating source in the winter at this point still remains a steam boiler. Can you talk a little bit about a little bit more about the hybrid heat pump? What is the fuel for the hybrid heat pump when it's not just electricity? Can it be number 2 heating oil, or is it natural gas based?
Yeah, no, hybrid just means it's a combination of 2 different things. So it honestly is anything. It could be your steam boiler. It doesn't have to even be integrated. It just means that you have another source of heating.
A secondary source.
Yeah, your situation is pretty common. I have a lot of clients that have steam boilers. Their house is big, and the kind of AC unit / heat pump they want to put in just doesn't have the BTUs to be the primary source of heat, but yet they still use it a good portion of the winter and then use the steam when they have to. I mean, there's always a way to get more heat pumps into your space. It just, how much money do you want to spend is the question.
And do those clients, if I can, do those clients have, say, for example, they got a 4-ton condenser unit, do they actually have more indoor units than the BTU rating for that 4-ton? And because you're able to designate which units are on at which time of the day, essentially, I don't want to say oversize, but overdrive the condenser, just not by running all of the units which have a greater BTU sum than what that condenser is rated for?
Yeah, it sounds like you have a great understanding of it. Yeah, that's pretty common. The sum of the indoor units is generally, sometimes sized larger than the outdoor unit, because you almost never have that perfect storm where all the units need to be on all at once at 100%. So there's a diversification that, yeah, some units are not on, some others are on. So there's always, BTUs delivered to the right spots. You can always kind of negate your shortcoming in BTUs with that. And yeah, quite honestly, if you're not meeting your full heating demand, you could keep adding more heat pumps. Essentially, you could, if you really wanted to, but obviously there's a limit to what you want to do and what your goals are.
Super. Thank you so much, Chris.
Yeah, thank you.
Okay, the next person with his hand raised is Thomas. So Thomas, can you unmute?
Sure. Hi, Chris. Question about the solar. I'm interested in possibly going solar now. A lot of questions around that. Like the solar panels. Who would actually own the solar panels would be like my first question. Second question is, I'm also more interested in the battery backup for the home in case like you lose power. Especially we have like wells, so our well pump, we lose power, we lose our water, that sort of thing.
Sure. So there are 2 kinds of solar deals that everybody does out there. It's basically, one is a lease. So that's what you're talking about. A lease is where you don't own it. And then the other part of it is a buy, where you do buy them with a finance or buy them. So my personal recommendation and feeling on it is basically, if you're going to generate electric power in your own house, you should own it, right? And the owning is the only point in time where you can actually take the tax incentives, right? Because you don't qualify for the tax incentives if you lease, and also the state SRECs. So those are big, huge financial gains, incentives, I call them, right? That benefit going solar, and the only way you can get them is if you own them. So leasing is okay in some situations, usually elderly people that just want lower bills for their monthly bills. A lease will achieve that for them, but that's about it, right? So if you're planning to stay in your house and you plan to reap the benefits of the tax incentives, you should own it. The other part is battery backups. Yeah, you can do battery backups. Batteries are expensive. So
Right.
If you have no way of getting a generator, which some properties you just can't, you don't have the gas or anything like that. So battery backups, you can install battery packs as many as you want. You just have to pay for them. And the batteries are good for a day or two, depending on how many you get. Again, for an average house, they're not, one misconception is that you can kind of run your house for a while. You really can't. I mean, a day or two will get you by on good battery pack investment, but they're very costly. Very few people actually get them because of the amount of money it costs.
Okay, because yeah, I was wondering about that that Tesla battery, house battery.
So just to give you an idea, it's about $12,000 for the first pack and about $8,000 for each additional pack. And an average house to fully power it probably needs 2 packs. So that's 20 grand. Yeah.
Okay.
Yeah. No, they're expensive.
All right. Thank you very much.
Sure.
Okay, thanks. And Michael and well, Thomas already turned his hand off. So Michael, could you turn yours off? The next person is Shoshana.
Hi, thank you. Chris, are the heat pumps also used for cooling? My understanding was that they were dual purpose, heating in the winter and cooling in the summer.
Yeah, absolutely. That's why I said the heat pump name throws people off. They stop thinking of it as an air. It's an air conditioner slash heater. It's both.
Thank you.
And Susan.
Hi, I was wondering, you mentioned a calculation for how much power you actually need. Would that be something a contractor would do for you, or is?
Yes, absolutely. So a good contractor, I'll stress the good part, should be doing manual J calculations as good industry practice. Now, the unfortunate truth is there's a lot of contractors who just don't know how to do it and don't do it. But you can definitely get third-party people too that just deal in purely that analysis, like an energy audit. There's companies I can even recommend. They'll just come to your house, they'll do that kind of calculation, they'll make recommendations on insulation and things like that, and it'll give you a good perspective on what your house really needs. If your house is leaky and how many BTUs of cooling and heating it will need. So you can get that independently as well.
Okay, I have a second question. You mentioned tax incentives for solar panels. Are heat pumps covered by this federal bill or no?
Yeah, so right here, this address I put up, it's very new. So
The rewiring?
yeah, rewiringamerica.org APP. So it's a cool little calculator if you guys go to it, where it will show you what the incentives for 2023 are, and they're not all clear yet. There's a lot of details to be worked out on the state level. So there's definitely going to be tax incentives and some other rebates and things of that sort available. Now, the only thing I will say is that usually the very, very high efficiency equipment ranks for this stuff, right? And it's usually the smaller equipment. So I wouldn't go chasing the rebate. That's what happens. A lot of times people chase the equipment that qualifies, but again, the equipment that qualifies isn't always the best for your design. So design is first. It's just like, if you want to run a marathon, do you choose the sprinter? So the sprinter may qualify for the rebate, but is it the right application for your house? So these kind of rebates are written by people who have no clue about design. They're in the government. They just look at some SEER rating, which is very hard to kind of put a blank statement on. So some equipment will qualify, some won't qualify. The tax incentive for getting a heat pump, from what I understand, you're supposed to get a tax incentive no matter what, but then there's additional rebates for qualifying equipment. All of it is still not super clear. So even if you go to this calculator, like everything will depend on your income level, and each state has to kind of come up with their own program for 2023, which hasn't happened yet.
Thank you.
Okay, we have one more question and then we'll turn it back over to Steve to introduce the next speaker. So, John, you have a question?
Yeah. Yeah, I do. Hi, Chris. Thanks so much for the presentation. Very informative. So I'm in southern New Jersey in Margate near the ocean. And right now we don't have any solar. We have an older home that we're looking to upgrade the HVAC. First question, and I have two. First question is, how do we find someone like you that would take a whole house approach? You know, I think if we go to just an HVAC guy, or if we go to a solar guy, they're going to want to handle their part of it. We're looking for, I don't know, if it's an electrical engineer or someone that can talk to us and understand the whole house approach we want to take. Where can we look for and find someone like that?
Sure, that's tough. Where are you again?
We're in Margate in southern New Jersey.
Okay,
Below Atlantic City.
yeah. So I could help you with solar, but not HVAC. No, that is a very tough one. I suggest there is a Facebook group called Electrify Everything. There is a person on there. His name is Nate Adams. He started a group where he's trying to get a bunch of contractors who are like-minded, and he probably has a good database of people that are like-minded. I don't really know of anybody similar down in South Jersey at all. It is a tough find. I mean, and I'll tell you, a lot of times it takes you as the homeowner to really pull things together, get educated enough. But if you follow that Facebook group, it's all about educating homeowners about how to electrify and choosing the right heat pumps and a lot of what I talked about.
Yeah. All right, great. It was Electrify Everything. And what was the guy's name?
Nate Adams. He is known as the House Whisperer. I think his book was called The House Whisperer.
Okay, one other quick question, if I can.
Yeah.
You talked about battery backup. What do you know, or what do you see coming, being able to use an EV as battery backup?
And even, well, I understand some of these EVs, you can plug them in and use them as the battery, right?
That's what I mean, yeah.
Yeah, that's a neat little thing, actually. I mean, I don't think every EV has it, but I know some of them. I think that's the trend. That's pretty cool. But then if you use that, can you drive out to work in the morning?
Yeah, no, I get it. I understand. But
yeah. Well, one thing that I probably didn't say, but the average house in the United States uses about 11,000 kilowatt hours a year. And the average EV will pretty much use 5,000 kilowatt hours a year charge at home.
Yeah.
That's half your usage. So that to consider as we move on and more of us have EVs, not just one, but some of us have two in a house.
yeah.
You're going to double the actual usage of your electric, at your house. So A, do you have it? And the other thing is how much is it going to cost you? So that's why solar is becoming more and more important.
Yeah. All right. Thanks again, Chris.
Thank you.
And Carol got her hand raised before I turn things off. So Carol will be the last one. And then if we have time at the end, and we probably will, we can ask more questions then. So Carol.
Hi, thanks, Chris. I just wanted to make a comment, and that is that nobody ever talks about it, but it is possible to have a ground mount solar system. The leasing companies never offer it because I guess they figure it costs more money or something. But if you have a shaded roof, or like in my case, my roof is extremely steep, so it's not really great for solar anyway. I have a ground mount system and it worked great. So that's all. Thanks.
Yeah, absolutely. You just have to have the real estate to have it.
Okay. Then we'll go back to Steve for the next person, and everybody that has their hands raised, please turn them off at this point.
And
make sure you're muted.
And we'll, at the end of this, hopefully we'll have time. We'll bring back all the questions. Thank you. Chris, that was a great talk. Thank you. You answered all the questions very well. And you said, people were asking, how do we find somebody like you where we live? So, well, if you're in northern Jersey, it sounds like you're the right person. Anyway, next, second speaker will be Franci, who wanted an ultra clean HVAC system for her apartment. And she went to Chris, and Chris came up with her answer. So Franci, I'm going to turn it over to you.
Okay. Hello, everybody. Thank you. Well, Steve made it sound simple, and it was anything but. It was a very arduous process until I found Chris. I just wanted to talk a little bit about what my learning curve was like. What were the important things that I think one must know about and keep in mind when switching over to this type of a system, and how to choose the right person to do it, because I think that is the most important thing. So I do have a background in healthcare, and I have been an environmentalist for a long time. And I suddenly started reading a lot of scientific articles about the health dangers of fossil fuel byproducts when using fossil fuels for heat and cooking and using clothes dryers and things like that in the home. The literature, the health literature is quite alarming if you start to look at it. Not only the dangers, like Chris mentioned, of carbon monoxide poisoning, but just the everyday exposure, mostly respiratory, of the byproducts that circulate in your home just from using a gas stove, a furnace, a gas-powered clothes dryer, are really quite startling. They produce what's called particulate matter, which are very fine particles that float through the air. It also comes from any kind of combustion energy source, such as cars and factories. But most people get exposed to it in quite surprisingly high levels just in their own home. And in fact, air quality inside most people's homes is far worse than anything they're going to breathe out of doors. So indoor air quality is really kind of an under-advertised health risk that most people are not aware of. It does things not only for cancer, but it vastly increases the rate of stroke, cardiovascular disease, as well as respiratory disease. So that was one part. And then, of course, being an environmentalist, I say, I don't want anything to do with fossil fuels anymore. So there were two very compelling arguments. The other thing is that in my apartment, it's a forced air system, so that there's ductwork that runs through my walls and ceilings. This is quite common in many people's homes and places of work. And the either cooled air or the heated air comes out of vents that are in the wall or registers in the ceiling or floor. And it always bothered me. It wasn't something that I grew up with. I grew up with old-fashioned radiators and no air conditioning. But it always bothered me is like, how do you keep them clean? Dust and these fossil fuel byproducts are getting blown through these vents that are distributing the air in all the places in my home. And I had talked to a number of people and they said, well, there's a lot of problems in trying to clean your ducts. It very often ends up disturbing things and only making matters worse. And sort of a deep dive into the literature on that from the Department of Energy, the Environmental Protection Agency, and other places sort of, back that up. It's not necessarily something that's going to help, and it may actually make things worse. So I started to think about it, and I said, well, the fossil fuel byproducts not being healthy, and ductwork that can harbor mold and bacteria in the dust that's in there, and not being able to clean it. I said, I don't really like these health risks in my home. The other part of it was what Chris mentioned, is that there are some cost savings to be had with electrification. And I think in the future, there'll be even more than we see now. So all in all, I said, this is a no-brainer. I think I need to switch to a ductless system so that I am eliminating vents that can't be clean, and to eliminate the fossil fuel byproducts in my family home. So then became the task of, well, what do I get and who do I get it from? I did, again, a lot of reading. There's a lot of good reading on the governmental websites from the Department of Energy in particular, also from the EPA. But it was very hard to integrate it. There would be certain things that were more energy focused, certain things that are more health focused, but not necessarily all integrated. So that was sort of something that I found I had to kind of put together myself. Chris mentioned something that I discovered was like the most important place to start when you're thinking of putting this into your home. And that's the manual J calculation. That's assessing what the particular needs of your home are in terms of heating and cooling. So if you live in a home, like I live in an apartment and we only have 2 exposures, one is northeast and the other one is southeast. So one part of the apartment, gets a lot of sun in the middle of the day or the morning, and the other one gets less. I also have very large windows. So these kind of things can change our heating and cooling needs compared to someone else's house who maybe has 4 exposures or maybe has 2 exposures, who maybe is surrounded by a lot of trees and shade, who might be in some place that is very windy. So it's not a one size fits all at all. A lot of people just look at the websites for manufacturers and they say, okay, well, if you have so many square feet, this is what you need. That's the furthest thing from the truth. And you will get into a lot of trouble if you think in simplistic terms. So you need an expert, and Chris was really the first person, after interviewing 10 contractors, who not only knew about manual J calculations, but also knew how to do them. And it was really quite shocking because I was working off recommendations of contractors and dealers that the manufacturers were rating as their 4-star platinum, top rated contractors in my area, which meant that they had gotten training from that company and how to size and install these units. These people just didn't know what they were talking about. If me as a layman, knew about these things and he didn't, these contractors didn't, I said, these are clearly not the right people, especially since, these jobs are pricey. So as Chris said, if your contractor doesn't know how to do these calculations to figure out what equipment and what size you need, it will be essential money well spent to get either an energy auditor or some kind of engineer to do that. I think I get the impression that the installation in many cases is really not that complicated, and you see lots of do-it-yourself stuff online for that. But you have to know that you're installing the right sized unit and the right unit. And actually, what I learned is that there's 2 kinds of units involved in these systems, and you have to be careful about sizing each one of them separately. The beauty of these systems is that you can have one room in the house cool and another room in the house warmer. Everyone can pick the comfort level that they want in terms of both the temperature and how much the fan is circulating the air. So if you have certain family members, maybe older people who don't tolerate cool as much, they can put it on 80 if they want. Other people can have it cooler. So you have to figure out the size of the room and the energy needs, the BTU, which is a measure of heating and cooling, British thermal units, it stands for BTU. You have to figure out what the heating and cooling needs are for each individual room. And you need to put a unit, if you're using the ductless systems, you need to put the appropriate sized unit in each room. So once you have the size of what is needed in each room. Then you have to add all those things up and figure out what is the size of the unit that will go outside of the home, the compressor that will service those inside units. As Chris said before, I learned that it doesn't always have to be equal, because it's rare that every single room is going to be heated or cooled at the same level simultaneously. So for example, if you're going to sleep at night, chances are you're only going to be heating the bedrooms or cooling the bedrooms for the most part. So that is a lesser total sum of your energy needs than if you had added up the energy requirements of all the houses in all the rooms in your abode. So the outside unit doesn't necessarily have to be as strong or as equal as the sum of all the inside units. So these are the kinds of things that I learned as I went along. And, this is, again, speaks to the whole idea of you have to learn how to size the inside units according to the needs of that room and make sure that the outside unit can service the energy needs for the entire home. So the manual J calculation, and Chris can speak to a little bit more of the details, but generally it looks at a lot of things such as the size of the room, the height of the ceiling, how many windows, how big are their windows, which way do the windows face? Do they face north? Or they face south, where they'll be getting a lot of sun? How many exterior walls are in the house? So for example, I live in an apartment, so it's not like a house that has 4 sides, the exterior walls. How many doors? A lot of factors, like whether it's on the first floor or on the upper floor for, in my case, in an apartment, whether the spaces above it or below it are heated or cooled. Like I live in a first floor place, so underneath it's not heated or cooled. So there's a lot of different things that are sort of, when you think about it, makes a lot of sense, but it took a long time until I finally spoke to enough people and learned enough about how this needs to be sized to realize that these were all the different factors that needed to be taken into consideration. So you really need an expert who knows how to look for these different factors. And then there's a scientific way of calculating how much one thing matters versus the other. And that's the manual J calculation. That's sort of like the formula, the recipe that it all adds up. So in my case, I'm living in an apartment and I only have 2 exterior walls, which presents a problem with installation. Generally speaking, I learned that it's much simpler to install these units if you have exterior walls to put them on in each room. Very simple. You put it on an exterior wall, they poke a little hole through that wall, and out of that comes a tube which drains the condensate fluid for the air conditioning in the summer. And it also supplies energy, the power source, as well as the heating and cooling supply to that unit in that particular room. But I don't have 4 sides. Every room did not have a wall that's available for the placement of an exterior unit. So I learned that that's something that, changes the ball game when you're putting it in an apartment. Doesn't mean it's impossible, just means you have to approach it differently, which I was happy to find out. So in my case, I have a lot of my units on interior walls, walls that are walls between the rooms, not walls between the outside and the inside. Because either it was impossible to put it on the exterior wall or that wasn't a good place in terms of comfort. So we run the lines that supply the energy and supply the heating and cooling through our ceilings. There's a drop ceiling, and actually they're very small lines. It doesn't take up a lot of space, but we removed some of our sheetrock, and Chris's guys were able to drill holes through the walls that needed to have holes drilled through them so that the lines can run through our ceiling travel to another room, join up with another line, and eventually make their way to the out of doors where they both drain the condensate fluid from the air conditioning in the summer, but also supply the heat supply for the winter months to the units. So there takes some creativity and design chops to be able to figure out what's going to make the most sense and how it's all going to fit together and work. So, you know, these are really, really important things that I found that most other contractors, like, you know, they just didn't know what they were talking about. It didn't make sense to me. And that's why I kept looking, because, you know, I was learning as I was going, but I said, you know, this doesn't make sense. This doesn't feel right. And, you know, and then I would talk to more people, or I would read more, and then I would find out, well, yeah, it didn't make sense because it just, you know, wasn't going to be practical. It wasn't going to work. It was going to create leaks or some other kind of problem if they had gone and done it that way. So, you know, it's like building a house. You know, you want to make sure that you build it right so that, you know, you don't have leaks or collapses or other problems later on. You need to plan this properly. It's not like just, you know, popping an air conditioner into your window. So you need to find someone like Chris who knows what they're doing, and will take it into consideration. The other interesting thing that I learned is that you save more money in the warm months than you do in the cold months. These units are incredibly efficient when it comes to the air conditioning part. They require much less energy to achieve the desired cooling effect that you'll want. And the air conditioning bills are much less than it was with my traditional central air. In northern New Jersey, you know, we require a significant amount of heat in the wintertime, although with global warming, that's getting to be less and less. So the savings were not as large, but it wasn't more than what I was paying for my traditional gas furnace. I was perfectly comfortable this winter. It wasn't the most severe winter, but I had no issues with the amount of heat that these units were generating for me. And, you know, it was very customizable. I could, you know, if it was temperature was dropping rapidly, I could ramp up the fan speed so it distributed the hot air a little bit more forcefully and warmed the room more quickly. You know, that's really great. And also it's like a remote control. So if it's the middle of the night and I'm feeling hot or cold, I can just, you know, press a button and change the thermostat without getting out of bed. So that's really nice to be able to customize my comfort that way. Let me see what other kinds of things. Oh, the other thing is that there's a lot of different brands out there. I chose the company that I chose based on not only its reputation for being reliable, but they happen to sell different sizes than other companies. And they sold a size compressor that matched up with my interior energy needs that would be closest. It wasn't oversized, it wasn't undersized. So, you know, if a company doesn't sell your size shoe, you don't buy shoes from them. So it was the same thing. There were other choices, there were other companies, but they didn't necessarily have the size unit that was right for me. I would have had to buy either units that were too big or too small with the other companies. So that's also important. Some contractors only deal with certain companies. Some only, you know, deal with Mitsubishi, or some only deal with some of the Chinese brands or Carrier. Although I think everything's pretty much made in Asia. I don't think anything's manufactured here. Also, different companies have different lengths warranty on their equipment. So that's important. Very big variation on that. The company I use has a 12-year warranty on their parts. I hope I never have to use it, but at least it's nice to know that it's there. What else? things like reliability ratings, it might be a great unit, but I want to make sure it doesn't break down. So you might want to look at that. I mean, first you have to look at what size you need, and then you can look at the choices of which companies sell the sizes that you would choose from. I did get a $2,000 credit from the state, although it was pretty expensive unit, so kind of only made a little bit of a help. But yeah, I think those might be improving with the new legislation. I'm trying to think if I haven't covered anything. Oh, and then the other thing is that what's really nice about these units is that they have filters to keep the air clean, and also to keep the units themselves running efficiently. You want to keep dust out of any kind of machinery because it's going to cause it to break down or not run efficiently. So the nice thing is that every unit in my house, I can pop out the filter and I just wash it with warm water and then let it dry and put it back in. So I don't have to purchase filters. I can clean them whenever I want. And that, gives me a sense of, that I have some control over the air quality in my house, that I can keep it clean. I do have it serviced professionally by Chris's guys twice a year, where they come in and they pull it apart more to do more thorough cleaning. And you can do, a deep clean every so often if for some reason you need to have it, where they can really just, take apart the whole machine and hose it down with special chemicals and water to literally clean every part of the machinery. So that sense of being able to control the cleanliness and the efficiency of the machine and being able to take care of it myself, well, more or less, together with Chris and his guys, is also a big selling factor for me. So again, to summarize, I think, the health considerations of these units are something significant to get any danger from the usage of fossil fuel byproducts and production of particulate matter, airborne particulate matter in your home, to get it out, because you don't have any of that with being generated. None of that is being generated by these units. Not having dirty ductwork to worry about, being able to clean the filters, being able to keep the machinery clean and operating well, not contributing to fossil fuel usage. And I'm hoping that over the long run, that the cost savings will also be something that I'll be happy with. So any questions, send them my way.
So thank you. And I'm thinking, I do see one question, but Steve, do you think we should go on to the third speaker and then take questions?
I think we should do that.
Time?
Yes. We had scheduled till 8:15. We can go over. I mean, there's no problem with the bridge if people want to stay over, but we should take questions at the end, because the next people, and I do, Franci, I really appreciate the information you gave us on health risks and the numerous factors for consideration. That's quite an earful. I thank you very much. The next speaker is Patsy and David from Central New Jersey, and all the advertising you've seen has their house featured as the house at the top of the advertising. And it summarizes basically what they've done with 16 years of electrification. So Patsy and David, I would like to pass the mic to you.
Okay. Go ahead. We're debating who's going to talk. So we've lived in this house since 1988, and we started upgrading the house in about 1996 with an addition that went on the back of the house, which you can't see, which included an air source heat pump. The original house had a oil burner, forced air furnace, as well as an oil burner water heater. So over the years, these are the improvements that we've made. In 2005, we replaced the windows. In 2008, we replaced the old furnace and the air source heat pump with the ground source heat pump, which we'll talk about in more detail. Let's see, in 2018, we bought an electric car. In 2021, we put a solar roof on the house with battery backup. And also in 2021, we replaced our electric water heater, which we had installed with the ground source heat pump. We replaced the electric water heater with an air source heat pump water heater, and we'll talk about that in a little more detail. And the latest upgrade is the replacement of our old gas lawnmower with a Toro electric mower. So this was the first major change that we made. Again, replacing an oil burner furnace and water heater, and standard AC for the main house, and the air source heat pump in the back for the addition. We replaced that with Climate Master systems. These are ground source heat pumps. They were sourced by our contractor. They were sized by our contractor, I would say, at 38 tons and 26 tons. We have a 2-zone system. Each unit has an electric coil backup. So this is sort of the hybrid system that Chris was talking about before. So if the heat pumps can't keep up with extremely cold temperature, the electric coils will kick on. Or if the heat pumps fail, you have electric coil backup. Variable speed fans to pump the air around the house at the optimum rate. So when the units are not running, the fan speed is relatively low. If they have to make up a big discrepancy in temperature, the fans will speed up. And so the 2 ground loops, this is the basis of the system. We have the system required essentially 2 holes to be dug, 375 feet deep each. And in each of those wells goes plastic tubing that's looped down and then grouted into place to ensure good thermal contact between the loop and the ground. And then that's routed into the house. I'll show you a picture of that later. Okay.
The alternative to digging 375 feet deep is to go down 8 feet and have horizontal loop. And we decided to go 375 feet deep because we felt there was less chance of damage to the loops. The other comment I want to make is we are using the term ground source heat pump instead of geothermal heat pump, which is the more popular term, because our nephew, who is a mechanical engineer, said, you really have to go to Iceland for geothermal. And so more correctly, it's ground source, that we're getting the heat and the cooling from the ground.
Right. Yeah. And at the same time that we did the heat pumps, we replaced the oil-fired water heater with a 9,000 watt Marine Marathon water heater. So that was the electric water heater that we eventually replaced later. So the total cost for this system was about $60,000. We eliminated, though, the use of 1,000 gallons of fuel oil annually. And our savings to date, we estimate to be about $46,000. The interesting thing why the electric, this item is highlighted, is that our electric bill didn't change going from the old system to the new system. I guess This always struck me as surprising because we were going from one heat pump to 2 heat pumps. So I figured our electric bill would go up, but it in fact did not. And I guess I attribute that to the higher efficiency of the ground source heat pumps to the air source heat pumps. And I think as Franci mentioned, maybe there was really no regular maintenance for these units. We've really done nothing to them in the however long since 2008, except to clean the air filters. I clean them twice a year for the bigger unit and once a year for the smaller unit. And the performance, we've been very satisfied with the performance, and they are nearly silent in operation. All the equipment is indoors, so there's no weather damage to the units. So this unit is actually sitting in our basement. This is the larger one. This is what the ground loop looks like when it enters the house. So the ground loop enters at this point, which is about 4 feet underground, and the fluid is circulated through both units using this pump. And the pump can be operated independently depending on which heat pump is calling for fluid, either heating or cooling. I highlighted this point because this is a critical advantage of a ground source heat pump system, in that the fluid that you're exchanging heat with remains constant at 55 degrees all year round, as opposed to outside ambient air, which can fluctuate, as you all know, between 20 degrees in the winter and 90 degrees in the summer. So we get extremely efficient air conditioning in the summer, and good heating in the winter. And if the heat pumps can't keep up, if it's extremely cold, then we have the coil backup, as I mentioned before, that will make up any deficit. So this is the key reason that we went with the ground source heat pump system, because we just felt that this was a much more efficient method of transferring heat from one place to another. Okay, so this is the new water heater. It's an air source heat pump water heater from Rheem, and it's also a hybrid system. So it has, in addition to the air source heat pump, it has a 4,500 watt resistive heater backup. I put in the uniform efficiency factor for the new water heater, which is 4, as compared to our old Rheem Marathon unit, which is less than 1. So there's a 4-fold factor increase in efficiency. This was kind of an expensive unit. The cost installed was about $4,000. The unit itself was about half that, and the installation was about half that. So it's relatively expensive, I would say. But this is what it looks like. The heat pump is up here. You can see the fan that keeps the compressor cool. The water tank is actually here. And I don't know if you can read this sticker, but that's the estimated annual energy cost for this unit of about $149. We installed this water heater as a part of an energy upgrade package, which included attic insulation. And because of the size of the overall package, we got a $2,000 rebate from state of New Jersey and a $5,000 interest-free loan. One thing I wanted to point out is the connection between the ground source heat pump that we use for the HVAC and the water heater. So this de-superheater loop is actually able to, in the summertime, when the unit is running in cooling mode, it can actually take heat that it has removed from the house and transfer it to the water heater. So it assists the water heater in keeping the water warm. So this is a loop that runs from the cold water supply through the heat pump and back into the water heater. So that's kind of an added advantage of this particular ground source heat pump. And this is where the ground loop from outside actually enters the unit. So the next big project that we did was the solar roof. So these are it consists of a series, and in this case, 196 active tiles, which are 58, produce 58 watts each. So the total of our system is about 11 kilowatts. And we have non-active tiles in low exposure locations. So this portion of the roof doesn't have any active tiles. This portion of the roof on the garage side, which faces north, has no active tiles. But there are active tiles on these two surfaces and this one, which face west mostly.
But you can't distinguish between them.
Right. Yeah, you can't tell the difference. They're all connected together. So the cost of this system with the roof, and I should say that we did this, and same for the furnace. We made these replacements at end of life for each of those systems. So the oil burner we needed to change, and the roof had reached its 25-year limit. So instead of putting an asphalt shingle roof on the house with solar panels, we decided to go with this Tesla system of solar tiles, and this is what it looks like. So the cost of the system at $55,000, to be honest, doesn't seem like it would be that much more expensive than an asphalt shingle roof with solar panels, but I didn't price that out, so I don't know that for sure. But as Chris indicated, currently there's a 26% federal tax credit. So our net cost for this roof was about $40,000. And then the state of New Jersey has what's called the Transition Renewable Energy Credit system now, which pays $91 per 1,000 kilowatt hours generated. So we have signed up for that system, and we're starting to receive those payments of $91 every time the system generates 1,000 kilowatt hours. The other thing, our electric bill is reduced each month by whatever power we send to the grid. So this is what our bill looks like. And basically, this number 605 is what we imported from the grid for the month of July, the billing period of July. This number at the bottom, 254, is what we sent to the grid during that period. So the difference between those two numbers is what we're actually billed on from JCP&L. These numbers, in case you're wondering, are the totalizing electric net metering system. So we've, since the system was installed in February of last year, we've imported about 20 megawatt hours from the grid and returned 4 megawatt hours to the grid. And in reference to an earlier question, we decided to install battery backup systems. These are Tesla batteries, obviously. They're each 13.5 kilowatt hours. These were $15,000, as Chris indicated. The batteries are not cheap. The net, though, after the federal tax credit is $11,000, so that makes a significant reduction. We've had several minor grid outages during this period, and you really can't tell. The lights flicker a little bit, but nothing like the computer, for example, doesn't go off. So there's really a pretty seamless backup when the grid goes down. And in the summertime, when we get sufficient sun, we can actually run the house overnight or when the sun is low on the batteries. And that's been very useful for us. This is just a view of the back of the house. So this is the addition that we were talking about before. These are active tiles on the back of the house, which is facing east. And this roof is the only one that's facing an ideal direction of south. This is what the installation looks like. I thought this would be interesting. Tesla hires a roofing crew to take off the old roof and make any repairs necessary, and then they install a weatherproofing underlayment. That's all this gray stuff here. And then the Tesla guys come out and actually install the tiles and interconnect all the tiles. This is what the back of an active tile looks like. So you can see the interconnection leads. And then these are clips that actually clip into brackets that these guys mount on the roof. So the tiles are easily removable for them if one of them fails, or if they need to get under the roof for some reason. They just clip out and clip back in. I don't know if this is a valid calculation or not, but I was kind of interested in the power output of the roof tiles versus sort of a typical solar panel that most people use. So the size of this tile is about 4.5 square feet, and at 58 watt output, that computes to about 13 watts per square foot. I just found this solar panel online, LG Solar. They have a 380 watt panel, which is 19.5 square feet in size, and that computes to about 19.5 watts per square foot. So you can see that the tiles are not quite as efficient. They're about 2/3 as efficient, I guess if that's the right term, as a solar panel. And that's I think been the characteristic since the tiles came out. Some of the results that we've gotten from the roof, this is from our Tesla application. I should say that the design estimate from Tesla thought that this system would offset our energy usage by about half over the year and generate almost 11 megawatt hours per year. So far, our current energy offset is a little over 50%. So we're on target, and we've generated a little over 7 megawatt hours of solar energy. So it looks like we're on target to hit both of these numbers. The distribution of the solar energy that's generated, 50% goes to the house, 25% goes to the power walls or the batteries to keep them charged, and then we end up exporting about 25% to the grid. And again, this is the total usage for the house through July. And so this just gives an indication of how often or how much power goes to running in self-powered mode. Again, summer only, because this is the only time we get enough sun to actually keep the power walls fully charged. And I'll show you that in the next slide. So about 40% of the time we're running, or 40% of the power goes to a true off-grid operation. And then just more money numbers. So we've generated 7 T-RECs to date. So we've earned back, or we've received back from the state $641. Our electric bill, we've always been on an equal payment plan. So this year, our electric equal payment plan was reduced from $250 to about $160, or a 35% reduction. So the estimate for our 2022 payments will be a little under $2,000. And if we get to 10 T-RECs, that will compute to $910. So you can see that we can anticipate a total electric bill for 2022 of about $1,000. And that's down, if you multiply 250 times 12, that's $3,000. So that's a 2/3 decrease overall. And just to show you what I was talking about, comparing winter performance versus summer, this is January of this year, so you can see the amount of power we generated was fairly low, 450 kilowatt hours. And our usage was fairly high. I think this gets to what Franci was saying. The systems have to work harder in the winter to heat. And then in July, we're almost at a net zero operation here. We're generating almost as much as we produce. So you can see that the amount that we're generating is 3 times higher than what we get in the winter, and the amount that we actually need is about half.
Less than half.
Yeah, less than half. And just so you know that we have Mother Nature's seal of approval. This is a great blue heron sitting on our solar roof. So as I indicated at the beginning, the other step that we've taken in electrification of our house was to buy an electric vehicle, which we did in 2018, a Tesla Model 3. That's not what this picture is. But to compare with our previous vehicle, which is a Subaru Outback. So at 50,000, we drove the Model 3 about 50,000 miles before we traded it for this car. And the Model 3 gets about 4 miles per kilowatt hour. So over 50,000 miles, if you multiply that out, the energy cost is about $1,750 at 14 cents per kilowatt hour, which I think is our current rate. So that's the total energy that we've used over the 3 years that we had the car, and this is the electric rate. As compared to the Subaru Outback, which typically got 25 miles per gallon, and we estimated an energy cost of about $6,000 for 2,000 gallons of gasoline at $3 a gallon. I just sort of picked that number for that period. I'm not sure that that's exactly right, but it should be in the ballpark. I should say with the new vehicles, the new Tesla vehicles, they are heat pump equipped, as opposed to the Model 3, which had an electric, resistive electric heater. So these should be more efficient. And then this car is more in keeping of the theme, with the theme of this meeting, which is heat pumps, I guess. And we can actually, during the summer, we can actually charge the car and the Powerwall and run the house while the sun is shining. We simply turn down the charge rate on the car so that it matches the roof output. We can charge anywhere from up to 12 kilowatts with the charger that we have in the garage. But if we turn that down to about 6 kilowatts, then that matches about the output of the roof and allows us to still run the house off the roof and charge the batteries. And for those of you who live in the Hillsborough area and want to be a Duke Farm volunteer, they are now offering free charging. Okay, so summary, since '96, we've gradually replaced fossil fuels with electricity. We started with an air source heat pump. We replaced our oil burner with a ground source heat pump HVAC system and electric water heater. We replaced our gas car with an electric vehicle. We had conducted a whole house energy audit. We replaced our old shingle roof with solar tiles and battery backup. Replaced the resistive electric water heater with the air source heat pump water heater. And then lastly, we bought this Toro electric mower. And if you're a customer of JCP&L, they were offering these energy saver kits, which included some LED bulbs and some LED night lights and crayons for your kids to actually color the box. And there are links here for additional information on any of the items that we talked about. And I think Chris maybe covered most of this, but this is what the new act covers: 30% tax credit for solar panel installation rebates on these items, and the $7,500 tax credit for EVs. I guess that's coming back for everybody. I'm not sure. Do you know? For Tesla, I mean, Tesla is out of the program now because they've exceeded the sales. So I don't know about that. But the other thing that's nice is for used EVs, there now will be a $4,000 tax credit, which currently doesn't exist. So that's it for us.
Patsy and David, that was super. I wanted to mention we're running very long, but that each registered person will receive a recording of this, so you can leave and then view later. What we've done in other webinars on occasion is to just continue on. If people have questions, sometimes the speakers are willing to stay until the last question's answered, and I don't know how you feel about that, but that's a possibility. We still have 28 people on the bridge.
Yeah, we can stick around.
Okay. Franci, are you still there?
Yes, I am. Can you hear me?
Yes.
Okay.
Can you stick around? And Chris, are you still there?
Yep.
Can you stick around?
Yep.
Okay, so Pat, why don't you take it away and see if people have questions?
Okay, Marty, do you still have a question?
Yes, I do. Actually, I have a couple, but let me start with Franci. I really appreciated your presentation and the fact that you live in an apartment and you were able to do these projects. I'm just curious how that worked out as far as any zoning issues that you had to deal with and negotiating with your landlord. It seemed like you were doing some significant adjustments to the physical plant of the apartment house.
Well, let me clarify, it's a condo.
Oh, okay.
A landlord, but there was the condo association to deal with. So yes, zoning, yes, I had to get a permit from the town, which consisted of submitting a survey of where the outdoor unit would be. Now, what I did is that I just swapped out where the compressor for my old central air conditioner was located, and we put the outdoor heat pump condenser in exactly the same spot. So that was, there was no problem with them because, we were just putting a piece of equipment in the same spot. So that was easy. The idea of altering the building, that was part of the creativity that we had to use. So because we had a outdoor air conditioner compressor, there was already a perforation in the envelope of the window through which the power and circulating refrigerant was coming. We just went through the same perforation that was there for the central air conditioning unit from before. What we did is we joined the different lines for the different interior units so that they would all converge and go out the same perforation in the envelope of the building. I also, used another, I have a door, so I went through the door frame to use that as another place where we went through the perforation of the envelope of the building. But it depends. If you could have just gone through, I could have just gone through the same single place. Where the central air was coming from before. So, there was no substantial alteration or change from what we had before. All the work was done basically interior to go through my ceilings. So we had to remove some of the sheetrock from my ceilings in order, for them to do the work in the ceiling. But it was really no different than what was there so much before compared to the central air conditioning lines that also travel through the ceiling.
Great. Well, thank you so much. It sounds like you're very happy with the solution that was designed and implemented. And I appreciate your sharing that with us.
I think you asked a great question. I had no idea to even ask those questions, when I was in the process of it. So, and different people contributed different ideas on how to approach it in terms of the placement of the units and the placement of the actual lines that needed to be installed. So that's why you need someone who really understands how the machines need to operate properly in terms of supply of refrigerant, energy source, and drainage. And then you can design it to fit the needs of the machine. But that's a really great question.
And one other quick question about the refrigerant. Is that similar to what's used in a refrigerator, or is it a different kind of refrigerant?
This is better to answer that.
Okay.
No, air conditioning refrigerant is going to be different than generally what they use in refrigerators or any low temperature system like that.
Okay. All right, great. And Chris, I really enjoyed your presentation too, but my next question is, if I can ask another one, is for Patsy and David. And Patsy, your name is familiar to me. Are you part of the Rutgers Environmental Stewardship Program? Is that
Yes.
ring a bell?
Yes.
I thought so. I appreciate your posts on the Facebook page from time to time. But I'm curious about what type of fluid goes in that underground system that you have that goes down, you said over 300 feet, is that right?
Yes, it's mostly water, but I think
Mhm.
there's, I think it contains some ethanol as, to prevent freezing, but it should never freeze
Mhm.
because the loop is at a minimum of 4 feet underground where it enters the house, and then of course it just goes down from there. But
Right.
it's primarily water, I think.
Uh-huh. And the Tesla tiles, you're the first person I've actually talked to who's implemented the Tesla tiles as a rooftop solution. Are you happy with that? How that's been
Yeah.
working out for you?
Yeah, so far, yeah,
Okay.
it's been about 18 months. Yeah, they seem to work fine, and the ability to run off the grid in the summer is kind of neat.
Mhm.
The house doesn't use too much power overnight, so there's plenty of capacity in the batteries to run the house overnight until the sun comes up the next
Yeah, I
day.
was curious about that. I have a little app on my phone that shows me how the battery drain occurs, from daytime to nighttime and all. And I imagine you have something similar for your battery backup system. I'm
Right.
curious, do the batteries run almost all the way down by the end of the night, or
No,
do you
we
still
were,
have a fair amount left?
yeah, it depends on where we start, but if we start at about 100% of capacity, we generally have 40 or 50% left by the end of the day, depending on how much the air conditioners are running. But we limit it we don't let it go below 35% just in case there's a grid outage.
And what happens in the wintertime when you get much less solar power? Do the batteries get charged through the grid?
No, no, there's no mechanism. The only time they get charged through the grid is when the system detects a major storm that might result in a grid outage. So the system will make sure that the batteries are at 100% in that situation, but otherwise they're never charged from the grid. So in the winter, we turn off the self-powered mode, essentially. We just set the reserve for the batteries at 100% because of the low solar output we get in the winter, they would never get fully charged in time to be useful.
And if you turn off the charging mode, do they hold the charge for
Yes.
any significant period of time, or?
Yes. Yeah, I don't think we've noticed any decrease in the
Okay.
capacity. Yes.
Great. Well, thanks for your patience answering my questions. I appreciate it. And thanks again for your presentation. I thought it was terrific. You guys have been a great example as to what's possible with some creative thinking and of course some investment dollars, because obviously there was a lot of expense involved in some of those different solutions that you implemented. Thank you.
Right. Sure. Thank you.
Okay, Michael, you have a question, I think?
Thank you. David and Patsy, that was amazing. And your third co-presenter there is so well behaved in the background.
That's because we're not singing.
Francine, your presentation was also great. David and Patsy, it's really cool to hear that you're using your batteries not just as a standby energy reserve, but at night. And maybe Chris, you can comment on, are there any concerns for battery powers in my future? We're waiting for the agency having jurisdiction to approve our phase 2 of solar in my house. Any concerns with using the battery at night, depleting it, then recharging it in terms of lifespan, or is the lifespan commensurate with the 10 or 12-year warranty, depending on whether you're going with Enphase or Tesla or some other battery?
If you're asking me, not that I know of, no, actually activity on a battery is good. The depleting it to a certain level, and actually what David said, yeah, you should never let it deplete all the way down. So keeping it at like a 30% minimum or something of the sort, and charging it is actually good activity. It's exercise for the battery. They say it's actually what you're supposed to do. So no, I mean it's meant to be charged, it's meant to be used, and as far as I know, it doesn't decrease the lifespan of it.
That is so good to hear. I can't wait to join David and Patsy down that road.
Okay, next up is Carol.
I just had a quick question. Chris, you keep talking about you work in Northern Jersey. What counts as Northern Jersey?
Well, it's flexible for the right job, but generally speaking, if you take Route 78 and up is
It's
our
Northern
frequent-
Jersey.
Was
Okay.
that? Oh.
Yep. Thanks.
Okay, June.
Hi, wonderful presentation, so interesting. I had a question for Patsy and David, or Chris. There are new alternatives to the Tesla solar roof. And I wondered if you had looked into any of them. I think GAF is one in particular. It's supposed to be a lot less expensive and possibly more energy efficient, although I don't know about that. Did you look at any alternatives to the Tesla?
At the time, there was no alternative.
Yeah,
I think these have come out since
yeah.
because we had them installed starting in January of 2021.
Okay.
I don't know, maybe Chris knows another, but we don't.
No, the JF roof is very, very new, and the jury's still out on it. It's more about there's lots of companies, lots of Chinese products out there that are solar panels / shingles. It's the reliability of them. How do they function as a real roof versus solar panels? And that, the jury's still out on it. Tesla had their fair share of issues as well with them. But happy to hear that you're fine. So no, besides Tesla, I wouldn't even recommend anything else yet, because they don't have the time trial out there.
I see. Okay, so I'm looking at putting a new roof on, and I thought if I was going to do that, this would be the ideal time rather than put the roof on and then throw some solar panels on top. So probably be less expensive to do it at one time.
Can you wait a year?
Probably not. I'm looking at some hail damage from the last big hailstorm, so this would be the time.
Yeah, we waited until our roof needed to be replaced. I mean,
Well,
that's,
yeah, I'm in that place now, so,
yeah, that's really the most economical way to do it.
right. But I'm now listening to you, I'm thinking, well, why am I not thinking about that? Because now's the time, I would guess, but Chris, you don't have any experience then with any of these other companies?
No, and if you want that Tesla roof, I'm not sure, Patsy and David, how long you guys waited, but it's a very, very long wait from what I hear.
Yeah, I don't remember exactly, but yeah, I think it was kind of a long process. Yeah, if you ordered it now, it would probably take a year.
Yeah. I'm told 12 to 18 months. They're really backed up and there's shortages. So it's a tough one.
Yeah.
Well, there's always TARP, right?
The other reason we went with the tiles, because we had been looking at solar panels for many, many years, but we just couldn't put enough panels on our house for what we needed. And maybe in your case, you can get the panels.
I don't think so. It just seemed that it would be kind of redundant and extra expense to put a roof on and then, hammer some solar panels in.
Oh,
Brand new roof.
well, actually, what we were calculating was the cost of a new roof and solar panels were comparable to putting on solar tiles.
Oh, okay.
Yeah, it didn't seem to be, at least at that time, it didn't seem to be that much more expensive. But I've heard that Tesla has really raised their prices. Maybe Chris has more current information. I mean, I looked, they had like 10 guys here for 2 weeks. And we only paid $55,000 for that roof. I mean, it sounds like a lot of money, but if you look at the amount of effort that went into it, I didn't feel it at the end that it was that expensive.
Okay, so some more calculations needed. Thank you.
Okay, looks like we've come to the end of our questions. Steve, do you want to say something?
Michael just raised his hand again.
Oh,
Okay, Michael.
Goodness, I think I was just trying to clap. Now I have both showing.
okay. Thank
But
you for the clap.
Thank you to all
Yeah.
the presenters and the organizers as well.
Yeah, thank you all for
I
joining.
have to agree to that. The presentations were outstanding, and I really appreciate them all.
21 people have hung in there until, what time is it? 8:40. Wow. Thank you very
Yeah.
much for
you.
hanging in.
Thank you. It's
we-
very interesting.
So
All-
we
all-
have more of this every month. So we hope to see you again September 15th, and you'll see announcements shortly.
Thank you so much, Steve. And
Thank you.
Thank you, Francie, too. That was wonderful.
oh, you're welcome.
And Steve, I saw your email. I will follow up with the woman that I mentioned to you, and we'll see what we can set up for October or November.
That'll
Okay.
be great. Thank you.
All right, great.
Also,
good.
Chris, when we have a chance, I have some new ideas for you. So we should be in touch.
Chris's
I think he's
apprentice.
gone. Okay.
Okay,
All right.
bye-bye.
Good night, everybody.
Bye-bye.
Okay, good night.